Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Today I will discuss about the inverse transformasi Laplace or Laplace transform, inverse of Laplace transform. Okay, so what is the inverse Laplace transform? So in last week we already discussed about the Laplace transform. Laplace transform is transform pair from the time domain. So the Laplace transform is from time domain or ft to this visual Laplace transform from ft to fs. This is the time domain, and this is the s domain or complex frequency domain or j omega c. This g okay, this g omega. This is the s domain. So after we find a solution in S domain, we will transfer back to the time domain. So if we transfer back, so this one is mean that this is the inverse Laplace transform. So if we can write the function in S domain by Ps per Ks, where the Ps and Ks are polynomial in Laplace variable S, and we assume that the order of Ks here is larger than Ps in order to be in proper form. So we can find the inverse Laplace by using the Heaviside and another method. So if Fs is not a proper form like this one, Ks must be larger than Ps, so we have to use a long division to divide Ks into Ps, so we get the remaining ratio of the polynomial that are in proper form. So if the Fs is not a proper form, it means that if, for example, Ks smaller than Ps, so the order of Ks is smaller than Ps, so we have to use a long division here to divide Ks into Ps until we get the remaining ratio of polynomial that is proper form. It means that the Ks, it must be larger than Ps. Okay, so if we can get the Fs in proper form, so we maybe we have a three case in here. The first one, case one, is if the Fs has all non-repeated simple roots. So like Fs is K1 per S plus P1 plus K2 per S plus P2 until Kn per S plus Fs per Pn. And then case 2 is Fs has a complex poles like P1S per Ks multiplied by S plus alpha minus G beta multiplied by S plus alpha plus J beta. So we can expand this Fs using K1 per S plus alpha minus J beta plus K1 accent per S plus alpha plus J beta. And then the case number 3 is Fs has repeated poles. So it's like P1S per Q1S multiplied by S plus P1 or S plus P1 R like this one. So we can expand like K11 per S plus P1 plus K12 per S plus P1 quadrat plus blah 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 until K1 R plus S plus P1 R plus P1S per K1S. So we will look for the example maybe to see more detail about three cases here. Okay, the case 1 illustration, the first one is if the Fs has all non-repeatable roots, like this one. So we have the fs like 4 multiplied by s plus 2 per s plus 1, s plus 4, and s plus 10. So if we have this equation, we can divide or expand the equation and using three rows like this one. Okay, this is the s plus 1, a1 per s plus 1 plus a2 per s plus 4 plus a3 plus s plus 10. So we can find the a1, a2, and a3 here by using the heavy side. So how to solve a1, a2, and a3 using the heavy side? The first one, we will find the a1. So the a1 is, this one is a1 per s plus 1. Okay, the first one we have to look for the equation here, and then we write s plus 1, s plus 4, and s plus 10. And then because we will see the solution of a1 here, so we multiply the this one, the 4 plus s plus 2 using the s plus 1 here. So this is the s plus 1. So we multiply by using s plus 1. So we can make a simple like this one, s plus 1, s plus 1, and then we will use the s is equal to minus 1 for a1 because the root is s plus 1. So s equal to minus 1. Okay, so by did this equation, we get that 4 per 27 for a1. And a2 is similar. a2 is s plus 4, a2 per s plus 4. So we have to write here s plus 1, s plus 4, and s plus 10. And then we multiply the upper equation using the s plus 4. That is the roots of a2. So we make a simple like this one, and then this s equal to this one, the s equal to s minus 4. So we by finishing this equation, we got that a2 is equal to 4 per 9. And then the last part is a3, the similar, we write this equation s plus 1, s plus 4, and s plus 10. And we multiply by s plus 10 when the s, this one, the s equal to minus 10. We got that a3 is minus 16 per 27. Okay, and then what is the ft? After we got this a1, a2, and a3, so we can write that 4 per 27 per s plus 1 plus a2 is 4.9 per s plus 4 plus a3 is minus 16.27 per s plus 10. Okay, like this one. Okay, so then remember that like 1 per s plus a, so this is the Laplace of e minus at, like this one. So the Laplace of a power of minus a minus at is 1 per s plus a. So if we have 4 per 27 per s plus 1, so it's like 4 per 27 multiplied by 1 per s plus 1. So like this one, 4 per 27 multiplied by 1 per s plus 1, like this one. And 1 per s plus 1, the Laplace transform is a power of minus t. So we got that 4 per 27 per s plus 1 is equal to 4 per 27 multiplied by a power of minus t. And then a2 is 4.9. And then this one is s plus 4, so this will be e power of minus for t. So we got that the inverse of 4.9 per s plus 4 is 4 per 9 multiplied by e power of minus 4t. And then the last part is minus 16 per 27 per s plus 10. So it's like this one is s plus 10. So the inverse is e power of minus 10t. So we got that this is minus 16 per 27 multiplied by e power of minus 10t. So this is the ft of this equation. Okay, so this is the case 3 and case 2 for a complex and repeated roots. Okay, so for the repeated roots like this one, okay. Okay, then for repeated roots like this one, we find the coefficient term as follow. So the Q1R minus 1 is the differential of S plus P1 power of R Fs when the S is equal to minus P1. And K1 R minus 2 is differential, the second differential per 2 S plus P1 power of R Fs when the S is equal to minus P1, similar because the root is similar. And then K1J is J power of R minus J ds power of R minus Js plus 1 R Fs when the S equal to minus P1. So it's like this one. This one is S plus 1 per S multiplied by S plus 3 quadrats is equal to A1 per. So we can make division of this equation become A1 per S plus K1 per S plus 3 plus K2 per S plus 3 quadrat. So this is for your assignment today. Please fill this one, A1. What is the A1? And K1 and K2 here. After this one, so please fill here. This is for A1, K1, and K2 here. So this is the assignment number 1. Assignment 1 for today. Okay, then if we have the complex roots like this one, P1 per S per Q1S S plus alpha minus J beta multiplied by S plus alpha plus J beta. So we can divide into two division, K1 per S plus alpha minus J beta plus K1 accent per S plus alpha plus J beta. So similar, we can find the K1 by multiply the equations by using S, because this one is S plus A minus J beta, so we multiply S plus A minus J beta. When the S equal to minus alpha minus J beta. So we got, after we got that one, the K1 is equal to K1 angle of theta, and then K1 multiplied by E power of J theta. Okay. Okay, so maybe we will look for this example. So this is the complex roots for the. So if we have the the Laplace of this one, if we can make like this one, so the inverse Laplace is this one, k1 e power of j theta e minus alpha power of minus alpha theta multiplied by e power of j beta t plus e power of minus j beta e power of minus alpha t and e power of minus j beta t. Okay, and then we can write this equation become this equation 2k1 e power of minus t multiplied by e power of j beta t plus theta plus e power of j beta t plus theta per 2. Okay, so therefore the inverse Laplace of this equation, the complex root, is this one. So you have to put this in your memory. 2k1 multiplied by e power of minus alpha t multiplied by cos beta t plus theta. Okay, so for example, find Vs, for given Vs, find Vt. So we have this one, s plus 1 per s multiplied by s quadrat plus 4s plus 5. So we can divide using this equation s plus 1 per, I mean that we can expand using this equation s multiplied by s plus 2 minus j multiplied by s plus 2 plus j. So we can arrange a per s because this one and k1 per s plus 2 minus j and k1 accent per s plus 2 plus j. So to find a, we have to multiply this equation by using s plus 1. Multiply by s because this is the s equal to 0. So we got that the a is 1 per 5. And then k1, we multiply this equation by using s plus 2 minus j. So we got this one when the s is equal to this is the s equal to minus 2 plus j. So we got this 0.32 angle of minus 180 degree. And then for k2, the s equal to minus 2 minus j here. Okay. And then we got total of the fs. This is from k1. This is for k1j and this is for k2. And then we got the fs is this one, 0.2 per s plus 0.32 angle of minus 108 degree per s plus 2 minus j plus 0.32 angle of plus 188 degree per s plus 2 plus j. And then we can recall from the form of the inverse complex root like this one. Okay, so we can find this equation. So we got that ft is the second equation and the second equation here. So we can write like using this one, 2 multiplied by k1 a power of minus alpha t cosinus beta t plus theta. So we got that k is 0.32. So 0.2 plus 0.64 to k1 a minus 2t cosinus t minus 108 degree. So this is the inverse of the complex roots, for example. Okay, so I think for today we already discussed about the first part of the inverse Laplace transform using the Heaviside. Okay, thank you for the attention. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.